Series parallel series combination of resistances. Tumingin na tayo rito sa libro. Example, so that you will have a reference. Okay, so this is from the book. Okay. So as you can see, in a problem that we have here, this is a different circuit as compared with the one that we have a while ago, no? This is a series parallel combination. Okay? Series parallel combination. For those of you who are asking, paano mo malalaman na ang unang connection ay series at ang pangalawa ay parallel? Because dalawa lang ang pwede nitong pagbagsakan. If it is not series parallel, it is in parallel series. The first one is your major connection and the second one is your minor. The next question is, paano mo alam kung saan ang major o saan ang minor? When you say major connection, this is the connection of the groups. When you say minor, these are the connection of the subgroups. Because in the circuit that we have two groups. Okay? The first group is the parallel group. Ito. Parallel group ito. The second group is the series group. So if this is your series group, and we have here your parallel group, your series group and parallel group are in series. So that is our major connection. Our minor connection, that is your parallel group. Okay? Next, let us try to determine now your total resistance RT. So RT is equivalent to, we always start with the most complicated part of the circuit. Paano mo alam kung asan dyan ang pinaka-komplikadong part? Yung pinakamaraming resistive elements, yun yung pinaka-komplikadong part. That is the easiest way to describe a complicated circuit. In this case, it is the parallel combination of 6 and 30 ohms. Okay? So 6 in parallel with 30. This parallel group is in series with 3 ohms. So the total resistance now is 8 ohms. Okay? Will you try to compute? I hope that you obtain the same value. Next is our I. The I that is given here is actually the total current that is being supplied by the source voltage, which is 48 volts. So you just have to make use of your Ohm's law. I is equivalent to V all over your R total, which is your 8 ohms, and that is 6 amperes. Ohm's law, V is I times R, or in terms of instantaneous values, V is I times R. Parehas lang yan. Okay. Next is our I1 and I2. We have here your parallel circuit. So all you have to do is to apply your current divider rule in a parallel circuit. Remember, when it is in parallel, you apply your current divider rule. If it is in series, you apply your voltage rather. You apply your voltage divider rule. Okay? Your I here will split into two parts. One will go into your 6 ohms and the other is in your 30 ohms. So by current divider rule, so I1 is equivalent to 6 amperes times 30 divided by 30 plus 6, and that is 5 amperes. Okay? Next, one of the properties for a parallel circuit is this. Total current entering into the parallel branch, that is your I, is the sum of the branch currents I1 and I2. We already have your I1, we also have your I. So all we have to do is to substitute. 6 is equivalent to 5 plus I2. So your I2 is 1 ampere. You can also counter-check this by applying your current divider rule. This is also the same as total current, that is 6 amperes times 6 all over 6 plus 30. And see to it that this is the same as the value of your I, which is the value of your I2, which is 1 amperes. 6 times 6, 36 divided by 36 is the same as 1 ampere. Okay? Next is your V. We can obtain your V by just applying your Ohm's law in your 30 ohm resistance. Simply your V is 30 ohms times your I2. So 30 times 1 ampere is 30 volts. O, yan lang. Okay? This is a direct and straightforward application of series and parallel combinations. Okay, let's have another example. Okay? Ito. A load requires 3 amperes and absorbs 48 watts. Okay? So mag-drawing tayo ng load. Yan. And this will require 3 amperes at 48 watts. If only 5 ampere current source is available, find the required resistance to be placed in parallel with the load. Okay? We will assume that the elements in question here are purely resistive elements. So we are looking here for the value of R. Okay? For those of you who are thinking, bakit kailangan mo pang mag-parallel ng R? Remember that our constant current source is capable of supplying 5 amperes. If this entire 5 amperes will flow into this 48 watt load, what will happen? Masusunog itong load mo because the amperage capacity of this load is only 3 amperes. You need to divert the additional 2 amperes into another load. That is why we have here your parallel resistance R. The required current here is 2 amperes. In order to effect the diversion of 2 amperes, what should be the value of R? Okay? We already have the power across the load. Okay? So we can compute for the voltage across this component. Supposing that the voltage here is given by V. The power equation that we have, power is V times I, correct? We have this equation last time. The power is given, the current is given. We are looking for only your V. So V is 48 watts divided by 3. So your V is 16 volts. This is the voltage across your 3 ampere connected load. And since this connected load of 48 watts is also in parallel with your R, it is understood that whatever voltage is across this element will also be the same across your R. The voltage across this must also be 16 volts. Okay? And we already have the current of 2 amperes. So if we make use of your Ohm's law, makukuha mo na yung R. R is V all over I. Your V being 16 volts. Your I is 2 amperes. Your R is 8 ohms. Okay?
Mayat natin, maawaray na ba ako? Kuray ba yung galing mo?
Okay, so this is our next problem. Find the voltage AB and the power delivered by the 5 volt source. The term here that is used is delivered, meaning it is providing power from negative to positive direction. So it is understood that the current is downward and all of the components are connected in series. Let us take a look in the voltage that is required. Voltage AB. How do we interpret this? Voltage AB is actually the potential difference between terminal A and terminal B. It is assumed that terminal A is at a higher voltage or at a higher potential comparing it with point B. At point B, this is at a lower potential. In electrical engineering, it is assumed that the flow of current will take place from terminal A to terminal B in this present setup. And if ever that nabaliktad, for example, terminal B is more higher than terminal A, then the current will be from B to A. But in this case, it is from A to B. So pag ganyan, the current will go from left to right. So this is your I. And since all of these components are in series, the current here is also I. The current here is also I. The current there is also I. Okay? First is, we need to find your I. Okay? If you try to sum up your voltages, summing up the voltages, it will be 10 volts plus 5. The sum of these voltage sources is always equivalent to the voltage drops of these resistances in series, which is your I times your 20, 60, 40, and 30 are in series. So that is 20 plus 60 plus 30 plus 40. So we can have your I. The value of I is 0.1 ampere. Okay? You might be asking, bakit pinag-add natin yung 10 and 5? How do we know whether we will be adding your 10 and 5? Because there are also instances wherein these sources will be subtracted. If you will try to take a look, if you have minus plus, minus plus, minus plus, your voltage sources here are additive because the series of your polarities are alternating. But if your polarities are minus plus, plus minus, this is the time that you will subtract, because the current that is delivered by E2 is against the current that is being delivered by E1. Okay? How do we find now the power that is being delivered by your 5 volt source? Basic equation of power by your 5 volt source is simply current delivered by your 5 ohms or by your 5 amperes times voltage across by your 5 volts. Current delivered by your 5 volts rather is equivalent to I, that is 0.1 amperes. And the voltage across your 5 volts is of course your 5 volts. So 5 times 0.1 is 0.5 watts. Yan lang, no? Okay? So I encourage you to practice solving problems in the book. We will have a series of these next meeting that will be tomorrow. Okay? Mag-practice kayo so that you will become very good in circuits. If you have a very good standing in circuits, you master your circuits, sisito lang yung mga nasa taas na subject. Okay? Good day to everybody.